This chapter is difficult to present and understand in a special way. An effort is required from the viewers to activate the imagination in order to understand the presentation. In this chapter we will explain how the Earth's rotation around the axis is formed and how the Earth maintains the stability of the rotation speed around the axis. It starts with the rotation of the Earth around the Sun. It continues with the gravitational force of the collapsing star in another universe which passes through a narrow opening of the black hole in two opposite directions. Along the Earth's orbit around the Sun, the Earth passes through the collapsing star's gravity. In the summer, in the northern part, and in the winter, in the southern part, and this for those who live in the northern part of the Earth. 5 days and twice a year, the gravity of the collapsing star is not active at all. This is because of the angle of exposure of the collapsing star on Earth, passing through a narrow opening of the black hole, which at this angle does not reach the Earth. Here is a simulation where we can understand better how the Earth tilts and how the speed of the Earth's rotation around the axis is maintained. The white rectangle is the gravitational force of the collapsing star. When the Earth enters the region where the gravity of the star is in collapse, it seems as if the entire northern hemisphere is exposed to the force of gravity. But no. Only the northern left part of the Earth, tangent to gravity, is the part exposed to gravity. At this point and until the northern hemisphere is half covered by gravity, there is a rotational torque that pulls and rotates the Earth around its axis. The torque is created that preserves the rotation speed. At this time, the tilt of the Earth begins. At the same time, the force of gravity of the star in collapse, which acts only in the northern part, causes the movement of the Earth in the y-axis towards the south. That is, a force that strives to take the Earth out of the axis where the gravity of the collapsing star is. In fact, the gravitational force of the collapsing star accelerates the speed of the Earth's rotation around the axis, but only at the perihelion. In aphelion there is conservation of the speed, and in the perihelion there is acceleration of the speed. Actually, at the end of the segment, there should be a counter-gravitational force that stops or slows down the rotation of the Earth around the axis, but since the Earth has fallen south, very little gravitational force of the collapsing star acts on the northern part of the Earth, so the force of conservation of the speed of rotation around the axis of the Earth is the dominant. Later, Earth reaches a gravitationally inactive region because Earth is at the poles of the black hole's exit. Later, because the Earth fallen south before, the Earth is now in a part where its southern side looks like to be completely exposed to gravity of the collapsing star. But no. Only the southern tangent is exposed to the gravitational pull of the collapsing star. Again, in the situation where the gravity of the collapsing star hits the southern part of the tangent causes acceleration and preserves the Earth's rotation around the axis. At the same time, the force of gravity of the star in collapsing, which acts only in the southern part, causes the movement of the Earth in the y-axis towards the north. That is, a force that aims to take the Earth out of the axis where the gravity of the collapsing star is. Thus, in the cycle of the Earth's rotation around the Sun, the speed of the Earth's rotation around the axis is maintained. In this way, all the planets maintain the speed of rotation around the axis.